Today I'm going to give you a brief introduction into statistical power. The power of a hypothesis test is the probability of detecting an effect if there is a true effect present to detect. To determine and define statistical power, we first need to consider the null and alternative hypothesis. To recap, the null hypothesis is an assumption about the outcome. In the Pearson's correlation test, the null hypothesis is that there is no relationship between two variables, whereas in the t-test, the null hypothesis is that there is no significant difference between the means of two groups. On the other hand, the alternative hypothesis is a position that states that something is indeed happening, often consistent with a research hypothesis. In the Pearson's correlation test, the alternative hypothesis would be that there is a statistically significant relationship between two variables. And for the t-test, the alternative hypothesis is that there is a statistically significant difference between group means. We can therefore understand statistical power, or the power of a hypothesis test, as the probability that the test correctly rejects the null hypothesis, so the probability of a true positive result. We can think of this in terms of type 1 and type 2 errors. A type 1 error is also known as a false positive. So, for example, an innocent person is wrongly convicted. A type 2 error is also known as a false negative, which, using the same example, we can think of as a guilty person being wrongly not convicted. The higher the statistical power for a given experiment, the lower the probability of making a type 2, also known as a false negative error, which we can think of as a higher probability of detecting an effect when there is an effect to detect. Therefore, the statistical power could be thought of as the probability of accepting an alternative hypothesis when the alternative hypothesis is true. Experimental results with low statistical power will lead to invalid conclusions about the meaning of the results. Therefore, a minimum level of statistical power must be sought. It is common to design experiments with a statistical power of 80% or better, which means a 20% probability of encountering a type 2 error. So we can define the statistical power as the probability of accepting the alternative hypothesis if it is true. Power is linked to the following factors in a statistical test. Firstly, the effect size, which essentially is the magnitude or strength of a relationship present in the data. Secondly, the sample size, which is the number of observations in the sample. And finally, the significance or alpha level, which is used to determine statistical significance and is often set at 0.05 or 0.01. All four variables are related, so a larger sample size can make an effect easier to detect, and the statistical power can be increased in a test by increasing the significance level. Power analysis is normally conducted before data collection, as its main purpose is to help the researcher to define the smallest sample size that is suitable to detect the effect of a given test at the desired level of significance. The reason for applying power analysis is that ideally the investigator desires a smaller sample because larger samples are often costlier. Smaller samples also optimize the significance testing. Power analysis assumes that samples have been taken at random and are independent from each other. It requires values for sample size, effect size, and significance level, which can be estimated from the literature and changed to test the individual effects on power. You also need to specify whether the test is one-tailed or two-tailed. A two-tailed test uses both the positive and negative tails of the distribution, unlike a one-tailed test, which uses only one direction of the distribution. You can do a power analysis in any statistical program, such as R or SPSS, and the type of power analysis you do will depend on the type of test you are doing. And that is a quick introduction into statistical power.